This giant 100-foot long turntable is one of the largest railroad turntables still in existence today. I'm Darren, and this is the Industrial Revolution. Built here in Spencer, North Carolina in 1924 to service this equally huge 37-bay roundhouse. This turntable was used to route trains in and out of the roundhouse for everything from routine service to things a little bit more extensive. Let's take a closer look at the turntable, and first, let's look at where they came from. A lot of steam locomotives have a nasty tendency to derail if they go in reverse. Not always, of course, and it's definitely not because they're steam powered. It's all about where they keep their wheels. So let's try to avoid derailing them if we can, okay? To be fair, some locomotive valve gear is actually tuned to be a bit more efficient forwards than backwards. So forward would actually be preferred in those locomotives anyway, but that was a choice the designers could either make or not, depending on where the locomotive was going to be used. I started trying to explain in detail why physics is a problem for steam locomotives going backwards. When I hit page 2 of the explanation, I realized that there's really just too much there for this video. So let's just say for now that it's because of the design of the locomotive, which often has no trailing wheels, and the design of the tender, and the way they're coupled. And when you put all that together, going backwards can tend to make the locomotive kind of bounce around a lot. And if you start to go fast enough, that bouncing can have some fairly adverse consequences. That's where turntables came in. First gaining popularity in the 1830s, one of the first uses for turntables was actually to simply turn locomotives around. Don't think roundhouse here. Think end of the line, probably out in the middle of nowhere. After stopping, they'd decouple the train from the back of the tender, pull the locomotive and tender onto the turntable, spin it around, then nose it back into what had been the front car of the train. The front of a locomotive used in these situations would have a standard coupler on the front. The locomotive has leading wheels, which help to pull it around curves, so you don't have any problems there. And the tender is still actually being pulled forward from the back of the locomotive. So all of your physics problems are mostly gone here. And other than the fact that you can't see, everything's fixed. This is a Gallows turntable, also known as an A-frame turntable, and it's at the Nevada State Railroad Museum. It's one of 3 main types of turntables. Now, in this turntable is actually 4 main components, and most of those are shared with other turntable types as well. First is the bridge, or the main table itself. Now, this is more or less just a standard bridge. It supports the track, the train, and it's the part that actually rotates. Second, you have a gallows or A-frame part of the turntable, and that's unique to the gallows turntable type, obviously. Using either cables or heavy timbers to the sides, it supports the whole track off the main central tower. The third main component is that huge ring you see under the bridge. That's called the central pivot, the bearing, or the spindle, and that's actually what lets things rotate. Now, all of these components are inside the turntable pit, which is really just a big hole in the ground to make room for everything else and to support the necessary components. What you don't have on a gallows turntable is any real support for the ends of the bridge itself. They're just kind of drifting out there, but it works okay for smaller turntables. Like the gallows turntable, this one at Expo Rail in Quebec, Canada, is a center-bearing turntable. It gets that name since much of the weight is on the center, but here you see there's also a circular rail running all the way around the outside of the pit, just inside the pit itself. And there's a pair of wheels on each end of the bridge, riding on that rail. You can see as they pull on, that the end of the bridge actually dips a bit and doesn't ride solidly on that rail. Both the weight and the rotation in this turntable are handled by the center bearing. The wheels on the ends kind of help hold things up, especially when it's off-center, when they're loading and unloading, and helps to guide the rotation a bit. But mostly everything is still handled by that center pivot point. In most center-bearing turntables, you need to get the weight fairly well centered or balanced across the spindle to allow it to turn easily. That's especially true if, like here, you're using what's called an Armstrong turntable. It's called an Armstrong turntable since it takes a strong arm to turn it. Typically, one or two people could turn a locomotive fairly easily. Notice that plate he's pulling out. It holds the table in place, locking the tracks in line to prevent derailment. It goes back in when the table's rotated into its final location before the locomotive is allowed to move. Most small turntables had some way of doing this, either like this or a lever that actually would just engage locks along the side. But bigger ones had another method. We'll talk about that later. A third type of turntable, fairly small and from what I can tell, fairly uncommon, is the rim-bearing turntable. I did finally find one in Ann Arbor, Michigan, with the Ann Arbor Railroad's 1916 Ferry Yard turntable. Named after the University of Michigan Ferry Field, which was home to the Wolverine football team at that time, the Ferry Yard was primarily used to deal with the large number of game day special trains bringing people from near and far to see the big game. Yeah, even more than a century ago, huge crowds were still drawn to major sporting venues. The yard was about a third of a mile, half a kilometer long, with a half dozen sidings to park passenger trains. It's a stub end turntable here, with no track off the southern end, and only one way on or off on the north end of the table. You'd park the train, unload, uncouple the locomotive, then run around to the turntable near the north end of the yard. Once you turned the locomotive, you'd then go recouple to the other end of the train for the trip home following the game. Each siding was big enough for one long train from maybe Detroit or Toledo, or maybe 2 or 3 shorter trains from other locations. You can see it's well hidden today by a lot of brush and protected by plenty of thorns and ticks. But if you're brave enough and lucky enough to find it, you can go down into the pit and even see directly under the center of the bridge to verify there's nothing there. There are other ways to turn your locomotive around, of course. First is the balloon loop. You come in on the string of the balloon, go through a switch into a giant loop, pulling the train along with you. At the end of the loop, you come back to the same switch, now on the other leg, and go back onto the same balloon string, but now you're going the other way. Now this takes a lot more room than a turntable, but you don't have to drop the train or push the train from the back one way. In a balloon loop, the only limits you have to deal with are how many cars you can fit in the loop and how sharp you can make the curve. Since railroad curves just can't be that sharp, and historically trains just weren't all that long, this wasn't usually much of a problem, and certainly isn't today for today's historic passenger lines. It's still a popular option at some historic railroads, like the Huckleberry Railroad here outside Flint, Michigan, and has the added benefit of giving great views of the train while going around those long curves. The other option is what's called the Wye. That's W-Y-E. A Y is the railroad equivalent of a 3-point turn. There's a lot of these around, but you can't normally see them very well. This video, though, shot in Silverton, Colorado, shows the Durango and Silverton narrow gauge railroad turning around one of its 2 daily trains in the Wye. The train pulls into downtown Silverton, right in the middle of the street, and drops off the passengers for lunch. Once everyone's off, the train slowly backs out around the curve to the edge of town, where it then slowly backs up into the Wye. The Wye here is long enough to hold a locomotive, a tender, and 15 cars. Conveniently, this is how long their trains are. Today, they have an extra locomotive, so they have to do a bit more shuffling. Once it clears the far switch, it then pulls forward onto the other leg of the Wye, going back onto the main line, but now headed the other direction. Now it backs up again, slowly, back around to where it dropped everyone off. When passengers return from exploring the town, the train is now pointed in the opposite direction, and almost no one ever even thinks about how it happened. And that almost brings us back to turntables.
Hey, just real quick here, and we'll get back to the video in just a second. If you can help me out, like, share, subscribe, all that stuff that really helps out the channel a lot. And comment. I love reading the comments, and I usually respond to them really quickly. Also, there's an affiliate store link down in the description. And if you can help out financially, either a super thanks here on YouTube, or become a member over on Patreon at patreon.com/industrialrevolution, or a membership here on YouTube. Thanks a lot. Let's get back to the video.
The other use for turntables is to switch a locomotive from 1 or 2 incoming tracks into a bunch of roundhouse service bays. But there's actually another way to do that too. This is called a transfer track. It's just a short section of track which is, itself, mounted on rails. Those rails allow the main track to move sideways. I've mostly seen these used where they're manufacturing locomotives or rail cars. But there is one other place where they're really popular. For roller coasters, which are really just specialized trains when you think about it, the wheels surround the track, so you can't use a normal switch. Instead, you have to use a transfer track. If you've ever ridden just about any roller coaster anywhere in the world, there's a good chance that you've seen these transfer tracks. Your only other real option is to use switches. A lot of switches. This is the Union Pacific Bailey Yard in North Platte, Nebraska. It's the largest railway switch yard in the world. We don't need quite that many switches though, so let's zoom in a bit. Each of these clusters contains 10 parallel lines, and this is just about as tight as you can pack things to get these 10 parallel lines. To fill the 37 lines you need to fill the roundhouse in North Carolina, you need 4 of these clusters, with all the land running up to them, which takes up about 9 acres, or about twice the space of a typical Walmart parking lot, or about 20 times the space used by this turntable. Now obviously a switchyard has to have room to park full trains, and a roundhouse only needs room to handle the locomotive and tender. So at a roundhouse, a turntable just makes a lot more sense. Let's go back to the North Carolina Transportation Museum.
So if we take a look at the turntable itself, so you've got one set of tracks, you've got a large wooden walkway on each side, and not every turntable had that. That's suspended in the large pit, and the metal plate here in the center, that's where you have the central spindle coming up. That the entire turntable rotates on that spindle.
Looking from the side, you can see the huge steel bridge structure, which could easily be confused as a 100-foot long, 30-meter long bridge used to span a river. Well, they're basically the same thing. The spindle itself is hidden here, but you can see the single rail around the perimeter of the turntable pit. Unlike the others that we've looked at, this is not an Armstrong turntable. It's a bit big for that. Instead, it's actually powered by a pair of 25 horsepower electric motors, one at each end. Some powered turntables were electric, some were steam powered, and some were even driven by compressed air. Although not normally open to the public, I was invited to take a look at the controls in the wooden control booth at one end. So this is it for the controls.
That's it. Forward, reverse, and stop.
So you've got forward, reverse, and just stop sits in the middle.
That's the switch off. Yeah.
Okay, and then this is your
That's the brake.
this is your brake, and this is just a friction brake onto the wheel down below.
It attaches to the lever, which makes the shoe tighten up.
And big transformer to for your
That's your electric.
two electric motors,
Yeah.
per 25 horsepower motors.
Yep. One on each end.
Not much in here, is there?
Not at all. 1920s technology.
And a little snowball at the bottom from Polar
That's
Express.
the L's. We have about 18 L's.
Normally they give rides on the turntable here, but in a recent inspection they discovered a problem. Although the bridge, rails, and everything else here are in good shape, they found that the concrete base for the spindle is cracked. Most of the base is actually buried underground in the turntable pit, and until they dig it up, they're not quite sure just how bad it is yet. They're currently only using the turntable when they absolutely have to move equipment with it, while they develop a repair plan and locate funding. So one thing I have not seen here, that I've seen in other turntables, is they'll have like a lever that actually locks across the rails to lock it in place.
The brake in there
The brake is,
is the only lock that I've ever seen.
okay.
And they'll stand out here in the brakeman till it's aligned.
Right, because you've got to get it to, an eighth of an inch or
Inside,
so.
got to align, yes.
Yep.
And the brakeman will do this, do that, and then once it's satisfying, you lock it down inside in the tightest notch.
Does that just like friction, like a post right onto the wheel, or does it actually go into to lock? Well, you don't have any place to lock really.
No, I don't think there's any. I think it's just a.
So it's just a friction brake,
Yeah.
and with the weight and the two electric motors not turning. So although this is, in fact, 100 feet long, and it's a huge turntable, compared to the alternatives, this is pretty tiny. To get into these 37 bays, you would need dozens of switches lined up. Every locomotive would have to go through 5 or 6 switches to get into here. These are going to be lined up a half mile or more out in order to hit these bays. And that's what made turntables so great. You can have a single track, or in this case, they have like a half dozen tracks that come into this turntable, and just pick where you want it to go. That's why turntables like this are the Industrial Revolution.